Hey everyone, Mike Raymond here. I want to go over biomechanical considerations, or just a few of them, from a standpoint of looking at squats and deadlift, as well as squats versus deadlifts. Once you look here from the left to the right, as you see a front rack squat. On the far right, you see a low bar back squat. And in the middle, you see a high bar back squat. Perhaps just pause the video just a little bit and just think broadly, like, what are you seeing here? What are some moment arms? What are the lengths of the lever arms? Those kinds of things. Pause it for just a little bit, consider it, and then move on the video, and we'll go over it here. If you plot it out, these are some things that you can see, and it's probably overwhelming if you look at all the colors and the dots and that kind of thing. So let's just kind of go through it individually here. And so same picture here, and if I just draw the line of axis as where the weight is going through, this is trying to represent where the mass of the bar is going through. And then remember, your center mass is going to change too, so that kind of depends on where the weight is going through the feet, which then is going to correspond, well, what is the length from the hip to the center of mass moving vertically to the knee, and accordingly. If we look at it here, here's the line of gravity going through the body on a low bar back squat. Here's the line of gravity going through a high bar and a front rack squat. That's what this dashed red line is representing. What you see here, this is where the axis, the yellow dot, it represents the axis from the hip. And then what you see with this dashed line is the distance from the axis of the hip moving to where that line of gravitational torque is coming from. So again, this is where the load is, this is where the line of axis of gravitational torque. Therefore, the hip has to function over this amount of distance, and then this amount. And you can see how this amount of distance is greater with a low bar back squat than it is with a front rack squat. And how does that, what does that mean? And we'll kind of get into that. If you look at the knee is going to be in purple. And what you see here is that line also changes as you go from a front rack squat to a low bar back squat. And what you see here is the distance from the knee axis to the gravitational torque, the line, is shorter than here or here. In other words, the hip internal torque is going to be much higher here than it's going to be here or here. The knee internal torque is going to be higher here than it will be here or here. And it's due to the distance from the axis of movement to where the line of gravitational torque is happening. Therefore, if we plot this out and we use plus signs as more distance, so you see a greater distance of hip from the axis of the hip to the line of gravitational torque, we see a much larger line here, or a distance that it has to function over, the hip has to function over, versus not as much here and even less here. With the red line here, what we're seeing is the gravitational torque. So remember, the gravity is trying to flex the hip. It's trying to lower the mass down. It's trying to bring the shoulders down towards the knee and the ankle, which is going to make the hip flex. Therefore, an internal torque is going to be required to counterbalance and or go against the external hip flexion torque. So the external torque is the hip flexion, and then the internal torque therefore is going to have to be hip extension, origin moving towards insertion. So that's what the green line, the green arrow is representing internal torque, and the red line is representing external torque. External torque, again, is trying to make the hip flex. Therefore, we have to counteract that, or this individual has to counteract that with using an external torque to try to eccentrically control the hip flexion, get to the bottom of the squat, and then concentrically contract and then pull back up. If we look at what happens at the knee, we get again, we're trying to bend the knee, so a knee external flexion torque, and therefore the quads are going to have to try to fire to try to eccentrically control the knee from going deeper into flexion, and then eventually, as we're going into concentric contraction, is now going to try to extend the knee. So an internal extension moment at the knee, and an internal extension moment at the hip, and an external gravitational torque of hip flexion and knee flexion. If we look at the distance from the knee over the toes, it's going to be, we use plus signs again. The more plus signs, the greater the distance. You can see that the distance is much higher here with a front rack squat than it is with the low bar back squats, especially with a low bar versus in a high bar back squat. If we look at the axis at the ankle, where the ankle's the axis of motion, we'll use a blue dot with that. We can see the distances there. And again, we're going to have an ankle dorsiflexion external torque, so it's trying to dorsiflex the ankle. Again, weight. Just imagine somebody's somebody's pushing down on their shoulders, and by just pushing them down, what you're going to get is hip flexion, knee flexion, and ankle dorsiflexion. Therefore, to counteract that, we're going to have an ankle plantar flexion moment to try to counterbalance the flexion moment, dorsiflexion moment at the ankle. So with a squat, as you have flexion, flexion, flexion from a gravitational torque standpoint, and extension, extension, and extension, or plantar flexion, which is an extension moment. If you look at it from a hip and head standpoint, you can see how that changes from that standpoint as far as where it is. So now the shoulder is in front of the gravitational torque versus behind, and definitely behind. And so therefore the center of mass is in front of the center of mass of the person. So therefore it's going to try to pull them forward. So they're going to have to use an extensor moment at their spine. Now, if we just look at from a standpoint of biomechanically what's happening at the different joints. If we look at the hip, you have a certain amount of hip flexion here, more here, and even more here. If somebody has a hip flexion intolerance, this would be probably the most problematic type of a squat to do. This would be the least of these three problematic standpoints. If we look at a patellofemoral standpoint, somebody has patellofemoral pain, and what we know from the literature is the more the knees go over the toes, the more patellofemoral compression we get. So therefore, a front rack squat is probably going to put more patellofemoral compression on a knee than either one of the low bar and or high bar back squats, especially the low bar. So if we just try to get some of the noise out of here, if we just compare a front rack squat to a low bar back squat, a front rack squat, the center of mass is behind the axis. The center of mass is still behind, but now we're in much more hip flexion. We have a shorter knee moment arm. We have almost an equal hip and knee. So the quads and the hip extensors are working relatively proportionally the same, but of course they have different strengths. I have more hip flexion, I have less hip flexion. Hip flexion intolerance is going to be tolerated better here than here. Ankle dorsiflexion intolerance is going to be tolerated less here and better here. Patellofemoral compression is going to be more poorly tolerated here than here. Somebody with patellofemoral compression probably will tolerate this type of a squat better than this type of a squat. This is how you use the line of gravity, the axis of the moment, what the distance between the axis is and a gravitational torque, how much flexion you're getting, how much joint angle you're getting, what is the external moment arm, what is the internal moment arm, is it functioning eccentrically, concentrically? All of these variables are things that you use from an exercise prescription standpoint. Now, if we look at squats versus deadlifts, and there's multiple different ways to do deadlifts. So here's what they call a Romanian deadlift, where you can see there's very little knee movement, therefore very little knee moment arm, and there's a lot of hip flexion moment external torque is going into a lot of hip flexion. Therefore, you have a big, an internal moment for hip extension. Eccentric control and then concentric contraction to come back up. A traditional deadlift, if you use a hex bar, so a hex bar deadlift, if you're more in an upright position, so you can see he's much more upright than this position. And even if he wasn't using dumbbells, even if he used a normal bar in weights, he would still have to get down lower. His shins would be more vertical, less dorsiflexion, less knee flexion, much more hip flexion, much more trunk control and potential spine extension. Versus here, his spine's more upright, less hip flexion, more knee flexion, more ankle dorsiflexion. So this is going to require more knee extensor torque, more ankle plantar flexion torque from an internal standpoint, and less hip extensor internal torque than this. So those are variables you can consider. So maybe just kind of pause the video for a minute and look at front rack squat, low bar back squat, Romanian deadlift, traditional deadlift, and just kind of, I've talked about them a lot already, but just kind of consider moment arms, internal, external torque at the joints, where the center of mass is, how much motion is at each joint. Just try to consider all those different variables. Again, therefore, if we consider a Romanian bar deadlift versus a squat, this is a low bar back squat. You can see you have a lot more hip flexion here, much more knee flexion, much more ankle dorsiflexion. So you have a lot more lower extremity flexion than you do over here. You still have a lot of hip flexion. You still have a big external torque for hip flexion. You still have a very large internal torque for hip extension, just not as much as here. And then you really don't have an internal torque for knee extension. It's mostly an isometric control. You don't have it really, so the center of mass and the line of gravity is anterior to the ankle dorsiflexion versus now you have a much larger plantar flexion moment than you do here. Now you're still going to plantar flex here, but it's more going to be to isometrically stabilize and hold versus here. If we look at deadlift, so much more hip dominant, you have a long moment arm, hip extensors, there's a lot of torque, a very short torque for knee extensors. Versus with a squat, depending on, are you doing a front rack, high bar, low bar back squat, and kind of showing. So you still have, it's a little bit shorter moment arm, still have a lot of external torque. Hip flexion, still a lot of internal torque, especially with a low bar back squat, not so much with the front rack. But now you have the knee is more involved here, especially with a front rack squat in the things that we talked about earlier. Additionally, you have a much more vertical tibia with a deadlift, more knees over toes here, so more patellofemoral compression. But again, remember, so even though you have much more hip flexion here with a low bar versus a front rack, and so with both of these positions, you have a lot of hip flexion. Most people will tolerate that amount of hip flexion and that amount of torque, and it's very normal. Most people will tolerate this amount of knee patellofemoral compression and torque. It just, perhaps in some individuals that have bad patellofemoral pain, they may tolerate this exercise better. We may start with this exercise and progress to this exercise. Those are just some things that you would want to consider from a standpoint of, how do I use the moment arms, the line of gravity, the internal torque, the external torque. So we still have a big external torque for hip flexion here and here. And we have also a knee flexion torque here, and we don't have it here. So those are some variables to consider when you're doing your exercise prescription. I hope you found this helpful. Take care.